The reflection loop has 4 steps: act, evaluate, reflect, react. Act. The agent produces an error or plan. Evaluate. A critic checks the answer against criteria like correctness, completeness, safety. Reflect. If evaluation fails, the agent generates a reflection. I made mistake X because Y. Next time I should do Z. Fourth step. React. The agent generates a new answer using the reflection as additional context. The loop repeats until the answer passes or a maximum attempts is reached. The reflection is stored in memory, for example, as a persistent string. The critic can be implemented in several ways: LLM-based critic, tool-based critic, heuristic critic, ensemble critic. LLM-based critic. Prompt a model to judge the answer. For example, is this answer correct? Output yes or no and a reason. Tool-based critic. Use a calculator to check arithmetic or a search engine to verify facts. Heuristic critic. Check for length, format or presence of required keywords. Ensemble critic. Combine multiple. For most language tasks, an LLM critic works well, especially if it is a different model. When the critic finds a law, the agent must generate a reflection. The reflection should identify the mistake, explain why it happened, suggest a correct strategy. For example, I incorrectly added 15 plus 27 as 52. The correct sum is 42. Next time I will double check my addition. The reflection is then stored and injected into the prompt for the next attempt. Reflections accumulate. The agent should maintain a reflection memory. For example, a list of strings. Each new attempt includes past reflections. This allows the agent to learn from previous mistakes within the same task. For long-running agents, reflections can be stored in a vector DB for cross-task learning. The reflection loop should not run forever. Set maximum attempts, for example 3. Convergence. If the answer doesn't change between attempts, stop. Time limit. Overall execution time. Also, if the critic's confidence is very high, stop early. For safety critical tasks, after max attempts, fall back to a human or a default answer. Reflection is an in-context method, no wait updates. It is cheaper and faster than fine-tuning. However, it requires multiple LLM calls per task. Fine-tuning bakes a correction into model weights, which is more permanent but expensive. Use reflection for dynamic tasks. Use fine-tuning for repetitive high-volume tasks.